Good day, everyone. My name is Sandra Nalin, the Bazooka Prophet, and today we are going to be working on a very interesting video in the field of organic chemistry, talking about what we call the alcohol. And we should understand that alcohol can also be referred to as alkanon, meaning that they both meaning that they are the same. And again, we should understand that alcohol are organic compounds in which the hydroxy group is attached to the saturated carbon atom. And of course, when you have the word saturated carbon, simply means that the carbon is singly bonded or singly attached. Is that clear? Now we should understand that since we've established the fact that alcohol is the organic compound in which the hydrogen group is attached to the saturated carbon atom, as you can see right here on the board. It is therefore important for us to know that this carbon atom that is saturated is an sp3 hybridized carbon, and as such, the general molecular formula for the alkanol is is arrow OH, where this arrow that you can see right on the board refers to as the alkyl group, and that the alkyl group can have CnH2n plus 1. So we continue. Now, as we make progress, we will understand that alcohol or alkanol can be classified according to the number of hydroxy group that is being attached to the saturated carbon atom. And as such, we have what we call the monohydric alcohol. That's what we call the monohydric, dihydric, trihydric, polyhydric. Now, when we get the word monohydric alcohol, it simply means that one alcohol group or an alcohol group is attached to the carbon atoms, and that is for monohydric. But in the case of dihydric, two, from the word di, it means two. So two hydroxy group are attached to the carbon atom, and trihydric, stereohydroxy group, as in the case of glycerol, and polyhydroxy group, as in the case of sugars. Now, for example, if I'm having something like this, CH3OH, this is an example of a monohydric alcohol. Why? Only one hydroxy group is involved. But in the case of CH2OH, CH2OH, this is a dihydric alcohol. Now, as in the case again of CH2OH, 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 this is a very good example of a trihydric alcohol. So we make progress. Now we will understand that in the case of the monohydric alcohol, it is further divided into three, depending on whether the hydroxy group is attached to the primary, secondary, or the tertiary carbon atom. That is to say, primary, secondary, tertiary is classified under the monohydric alcohol. So we continue. Now, when you use the word a primary alcohol, simple. A primary alcohol is an alcohol, or it involves only one alkyl group. Please take note. Only one alkyl group being attached to this carbon carrying the hydroxy group, as you can see. You see now, only one alkyl group attached to the carbon carrying the OH. It means that these two hydrogen atoms here, they are free in the case they are free in the case of primary alcohol. They are attached to the hydroxy group. So in some cases, I can be having something like this: CH3, CH2, then can be having C double H, CH2OH. This is an example of a primary alcohol. Now you may ask why. Remember that we have said that a primary alcohol is an alcohol that has only one alkyl group attached to the carbon carrying the hydrogen. If you look at everything here, are all the alkyl group attached to this carbon, or this H2 here, are still be intact, as you can see right here on the board. Now we move to the secondary alkyl, and we denote the primary alkyl group as 1 prime, while the secondary 2 prime, tertiary as 3, of course 3 prime, if I will put it in this regard. Now a secondary alcohol is an alcohol that has two alkyl groups attached to the carbon carrying the hydrogen group. You see that only one hydrogen atom now is free. While in the case of the tertiary, we have, you can see, 3 alkyl group attached to the carbon carrying the hydrogen. Please do not confuse this aspect, because a lot of persons do have issues with it, not knowing how all these things are played out. So it will be very good for you to understand it. So okay, let me wipe the board and do other examples. Okay, for example, I'm having something of this nature: CH3, CH2, having CH3. Okay, as I'm having C, H, then I'm having OH. Okay, I'm having, okay, then let's say, yeah, I'm having something like this. Now, this alcohol here, let's look at it. This is carbon carrying this OH here. So it means this group that are here, this one is the first alkyl group, this one the second alkyl group. You are having one hydrogen atom here still being left. So it means that this is a secondary alcohol. Then we move ahead in going deep to the family of the alcohol. Now we should understand that alcohol is a wide range of organic compound, and that the first 5 members of the alkanol are water soluble. It really be that the oxygen atom present in it is capable of hydrogen bonding. Is that clear? The first 5 members of the alcohol, which is the methanol, ethanol, propanol, butanol, and the pentanol, they are water soluble. Really be that the oxygen atom is capable of what now? Is capable of hydrogen bonding with water. Now, why from the 6th member of the alcohol, starting from the ethanol down to the rest other members, they are insoluble in water. And why? The reason because the alkyl group is non-polar, and because it is non-polar, it will be impossible for it to be dissolved in water. That is the main reason. Please take note of these points I am releasing. And again, we should understand that all members of the alcohol are soluble in organic solvent. Take note, they are soluble in organic solvent. Now, again, we should understand that alcohols are capable of hydrogen bonding, although to a certain degree, in the sense that there's what we call steric factor. Now, steric factor or steric hindrances has some degree of effect on the monohydric alcohol, talking about the primary, secondary, and what now, and tertiary, in the sense that the more the alkyl group, the restriction, the restriction, it will be for the hydrogen bonding to occur, in the sense that in this case here now, as you begin to progress from primary down to secondary, the hydrogen bonding, what now? The hydrogen bonding decreases. Take note, look at it. The hydrogen bonding decreases. It means that hydrogen bonding is high in primary alcohol but least in tertiary alcohol. While in the case of steric hindrance or steric effect will decrease as you move from tertiary down to primary, telling you that tertiary alcohol has more steric effect, or steric effect is high in tertiary alcohol because of the presence of more alkyl group in it, but least in primary alcohol. So it means any substance can come in. But as we begin to move from primary to secondary to tertiary, the ballgame changes. That take note that hydrogen bonding is high in primary alcohol but least in tertiary alcohol, while steric effect or steric hindrances is high in tertiary alcohol but least in primary alcohol. Now, this is just the part one of this topic that we're about to that we have embarked on, which is alcohol. In the part two, we'll be talking about the nomenclature of alcohol. Please, if this video has done well to you, do well to subscribe and please share to your loved ones. I remember my humble self, and Adrenaline, the Bazooka Prophet. God bless you.